Hello, welcome to video lectures on vector calculus. In this video, we will discuss the topic vector valued functions and their graphical representation. We have already studied the vector valued function rt is equal to x to a plus y to j plus z to k, where a less than or equal to t less than or equal to b represents a vector valued function for a single variable t. In two dimension, they represents curves drawn on xy plane, and in three space, they are space curves. As the parameter changes in Rt, the points are moving and the locus of these points will be a curve. Here we consider some examples of vector valued functions in two space. See, the vector valued function Rt is equal to cos ta plus sin tj defined for the interval 0 less than or equal to t less than or equal to 2 pi. As the parameter changes, we can see the points are moving. At the starting point t is equal to 0, we are at 1, 0. See, these are the locus of points, and these locus of points will trace a unit circle. So that is the curve represented by the vector valued equation rt is equal to cos ta plus sin tj for 0 less than or equal to t less than or equal to 2 pi. Now we can differentiate this curve rt is equal to cos ta plus sin tj to obtain r dash of t, and we know that r dash of t is the velocity vector acting in the direction of increasing parameter. See, the direction of trace is the direction of increasing parameter. Now see the velocity vector. So that velocity vector is also in the direction of increasing parameter represented. This is the blue vector is the velocity vector, and simultaneously we can draw the acceleration vector, that is r double dash of t, and that is given in another color. That is the acceleration vector for this equation. Now we can see the entire trace. Trace is the unit circle given by x square plus y square equal to 1. So the alternate way of representing the unit circle is rt is equal to cos ta plus sin tj. Now we can consider different curves. See, another example is the logarithmic spiral. See, the equation of the logarithmic spiral is rt is equal to e raised to 0.20 cos ti plus e raised to 0.20 sin tj for t varying in the interval minus 20 to 10. So that will trace the logarithmic spiral. See, as the points, as t is increasing, the points are plotting. See the complete locus of the points, that is the logarithmic spiral. So for this logarithmic spiral also we can draw the velocity vector r dash of t, so that r dash of t is acting in this direction. For this logarithmic spiral, velocity vector is given in blue color, r dash of t, and r double dash of t represents the acceleration vector. We can simultaneously draw both velocity and acceleration. This is the equation represented by rt is equal to cos ti plus sin 3tj for 0 less than or equal to t less than or equal to 2 pi. See, as the parameter changes, it will trace a curve. Also we can compute the r dash of t vector and r double dash of t, and that r dash of t vector is acting in tangential direction to the curve, and this is the acceleration vector. Simultaneous view of both velocity vector and acceleration vector. See the quadratic graph given by the equation rt is equal to ti plus 0.20 raised to 4j. The parameter is changing from minus 22. As the parameter is running from minus 22, it will trace a curve like this. The direction of increasing parameter is given. So as the parameter changing from minus 22, that will trace a curve. X is equal to t, y is equal to t raised to 4. This is the direction of velocity vector. This is the acceleration vector r double dash of t. The view of r dash of t and r double dash of t simultaneously. And for this interval we can define the usual parabola. The parabola is given by x is equal to t, y is equal to t square. Suppose we are defining this second component as t square, then it will trace the parabola. See, x is equal to r of t is equal to ti plus t square j, or x is equal to ty is equal to t square for minus 22. See the trace. See, this is the collection of points, and the complete trace is like this. It will trace the usual parabola. Direction of action of r dash of t, or the velocity vector. Direction of action of acceleration vector r double dash of t. The simultaneous view of both velocity vector and acceleration vector. So these are the graphical representations of vector value functions in 2 space. Thank you.